I don't have the Excel in my computer, so I'm showing you here. The first question, question number 1. Okay, the exponent rules. I'm going to give this. And you see the tiny, small last question, exponent rules. So definitely this one and this one. So these are 2 questions. So you left with 4 more questions. The 4 more questions will be from question 2 to question 8. From 2 to 8, see 2 to 8, they have multiple parts. But what I'm going to give you is no multiple parts, straight 4 questions, no multiple parts. And I'm not going to give these 2. 5 and 6, you don't have to study. I'm not going to give 5 and 6. So you have to study question 2, 3, 4, 7, 8. So from here, I study everything except question 5 and 6. Okay? Everything except question 5 and 6. Like which numbers? Which question you're talking about? All the numbers are easy here, right? I didn't give anything big. The highest we have is what? 3 square and 7 square. You know 7 square. So that's the highest number I give you here. And then we have 20 and 10. I give you 20 and 10 because it's easy. 20 plus 10 is 30. 20 times 10 is 200. You don't have to multiply, just 0. And the last question, I actually did not make the last question. It was from the department. So you'll expect to see this type of question in the final exam. So nothing in this page actually I made. Everything was in the final exam before. Okay. No, I said between the 2 exams, whatever is the highest one, I'm going to take the highest score. Okay. And this exam, the makeup one, doesn't have any partial credit. 6 questions, no partial credit. Either you get full credit or 0 credit. Okay. And between the old one and the new one, whichever is the highest, I'll take the highest one, highest score. So in our last class, we did 7.5 and 7.6. 7.6 is almost done. I just want to go over one question. And I don't understand why this question is the 7.6. It should be in the system of equation. But anyway, so let me refresh your memory with what we did with the word problems. For word problems, there is only one question that is important, working together. Either you work together or some type of pipes, they work together to fill out a tank, okay? Something like that. The main idea is working together. Anytime you have more things to work with and you're working together, just remember the formula. 1 over person 1 plus, always plus, 1 over person 2 plus 1 over person 2, whatever time we need for each individual person or each individual pipe or anything, you just add their time, and then the sum is 1 over that together. And whatever you don't know, that's the x. X is not a specific thing. X is not always together. It's sometimes if you don't know how long one person works, that is X. If you don't know how long it should take if they work together, that is X. So whatever you don't know, that is your X. Everything else will be given to you. So once you have your equation, all you have to do is keep 1 over x on one side and everything else to the other side, and then add or subtract whatever you have. And then just flip it. That's it. So 3 things. The formula, remember, in this formula, all the information will be given. all the information will be given. Whatever you don't know, that's it else. Based on that, you get your equation. So second thing, make the equation. The third thing, keep 1 over x on one side, everything else the other side, and then flip it once you add or subtract the one side. Okay? So it doesn't matter which scenario you see, that's all you have to do. We did 3 questions, and now the last question of this section. About to travel 48 miles with the current in 4 hours. Real life scenario. Where we don't use boat, we use cars often. So let's say we have water and you have a boat. Okay. Now, we have 2 scenarios. Either you're going with the current or you're going against the current. Okay. Like accelerator, if you go up the accelerator, you have 2 speeds, your own speed and the speed of the accelerator, right? Like if you walk on accelerator, so you're walking with your speed and accelerator has its own speed. So the 2 speed adds up and then you get faster movement. Same thing we have with the water. When you're on the water, you have 2 scenarios. Either you're going with the current, but the current is flowing one way and you are going the other way, just against the current. So if you're going with the current, you have faster speed. If you're going against the current, you have slower speed. So we get faster speed because your speed and the current speed, they all add up. They both add up and we get faster. On the other hand, if you're going against the current, there are 2 different speed, right? So you have friction. So that's why it's slower. So you have to subtract the speed of the current from your speed. Okay, so 2 scenarios. If you're going with the current, your speed plus the current speed, you get the total speed. If you're going against the current, then you have to subtract the speed of the current from your speed, so you get a slower movement. Clear? Real life scenario. Any question? Okay. Now here it says you have a boat and you're traveling 48 miles. From here to here, 48 miles. When you're going with the current, so the current is flowing this direction, and also your boat is going this direction. When you're going with the current, you're crossing 48 miles in 4 hours. So what is your speed? What is speed? Speed of a car. How do you write speed of a car? Is it only mile or only hour? Miles per hour, right? What's the speed of your car? Some miles per hour. So what's the speed here? 48 miles in 4 hours. So when you talk about speed, we talk about in 1 hour. In 1 hour, how long you go? So speed is distance over time. So we have 2 scenarios. In the first scenario, your boat and the current, they are going together. They are crossing 48 miles in 4 hours. So that is our speed, which is 12. 12 miles per hour. Because you're crossing 48 miles in 4 hours. So how much you are crossing in 1 hour? 12. That's the speed. How much you cross in 1 hour. So when people ask, what is the speed of your car? It means how much your car can go in 1 hour. So with the current, with the current and your speed, V means your speed, your boat, okay? So speed of the boat and speed of the current, they're working together. So we add them, and we have a faster speed, 12 miles per hour. So we got the equation for the first line only. We didn't write the second line. We just read the first line and it came up with this equation. Any question? No question so far? Now the second line. The second line says, the same boat takes 6 hours to come back against the current. So you went somewhere to your friend's house And now it's night, so you have to come back. When you come back, let me change my color to purple. When you come back, you are moving this direction, but the current is still moving in forward direction. So the current on the water, it's moving forward, but you are moving backward. So you have a friction, right? Obviously, speed has to be less than 12, right? Because now you have a problem. You're going against. For example, think about accelerator. The accelerator is coming down, but you are moving up. Will it take longer or faster for you to reach on the top? Accelerator is coming down, but you're trying to move up. Like, will it be faster or slower for you? Slower, because you're going against the accelerator. Same thing, the water is moving down, but you're moving up. So obviously you have a slower speed. So that time, since the water speed is going one direction and your speed is going another direction, so you have to subtract the speed of the current from your speed. And you're crossing the same 48 miles because you're moving from your friend's house. You're coming back from your friend's house to your house again. The distance doesn't change. The distance is still 48 miles. So you're still crossing 48 miles. But now how long it takes? 6 hours. So what's the speed this time? 8 miles per hour. See? It's slower than the 12. Now I have a question. Why I did not write C minus B? C is the speed of the current, B is the speed of the boat.
Current is acting against the speed of the boat, not the other way around.
True. And you can also think as, obviously boat has higher speed than current, right?
Yeah.
So that's why you're, so boat is moving with a current. I mean, obviously boat has a higher speed, right? In real life, boat has higher speed than current. So that's why you're subtracting the smaller one from the bigger one. So it's boat minus current, not current minus boat. When do we have current minus boat? Can you guess in real life? When that happens? I think it happens in the storm, right? Storm has the current has higher speed than our boat, so our boat can't go forward. So in a storm, it's other way around. But in normal situation, current is slower than the boat. So that's why it's B minus C, not C minus B. If this is oil, when you're coming back, there was a storm and you're coming back from your friend's house to your house, then you should be C minus B. Okay? So all of this is just based on the real life scenario. Nothing fictional. Any questions so far? Okay, so we have two equations. B plus C is 12, B minus C is 8. Our goal is to solve for both variable. That's why I said this should be the system of equation section. Yeah, why do we have it here? So how do you solve system of equations? Do you remember? Chapter 4, we learned that. How? Yes, you can plug, but you can just take B minus C, right?
I'm not sure.
If you want to plug, then you have to solve for one variable, and then you can plug. But can you think of other method easier? Elimination, right? Variable equals what? These are already variables, so you don't need the x. Like b is like x, is like y. As long as you have a variable, it could be any variable. The main idea is we have two variables and we are going to solve them. So you have three choices. Either graph them, which is not good idea. And then what's the second one we learned? Substitution. So solve for one variable, substitute that into another equation. Or the best one here is elimination. Just add the two equations. If you add the two equations, what happens to the C? The plus C and minus C, what happens? They cancel out, right? So what is left on the left side? How many B's? 2B. 2B equals, we are adding them, right? 20 miles per hour. So I divide by 2. Then what's the speed of the boat? 10 miles per hour. But they want to know what's the speed of the current. So if you know the speed of the boat, can you know the speed of the current?
Now you can plug this.
Great. We know B plus is 12, and we already know B is 10. So how much is C? 2 miles per hour. That's it. If you see in the final exam, probably this will come in the final exam. If they give you the board question. Usually they don't give this board question, they give the other one working together. Normally, okay? But sometimes they also give this one. So these are the two candidates from this section for your final exam. That's why I want to cover these two. In your homework, you have so many different types of questions. I had a video, but my previous YouTube account got terminated, so I have no more videos from my previous classes. So I cannot help you. You just have to do them by yourself. Either go to the tutoring or ask AI to help you solve it instead of just solve it. Or just search them on Google and then you'll see the steps. Just follow the steps. Try to understand them. And if you have any question, you can just ask me. But if you ask me, better ask me before the class. I mean, because I don't even know many questions myself. So I have to do them myself. So email me and then I'll cover that in class if you need anything, any help with any of the other questions in your homework. Any questions so far? Okay, we are done with 7.5, 7.6, and now we are going to a fun section, 7.7. 7.7 is fun, even though it says complex fraction. So we have a fraction, but this time we have double fraction. Fraction divided by fraction. That's why it's called complex fraction. But still it's fun because there are only two ways you can solve any of them. If you have a single fraction divided by a single fraction, for example, if we have something like A over B over C over D, A over B is one fraction, C over D is one fraction. So if you have a single fraction divided by a single fraction, all you have to do is keep, change, flip, and then cancel, multiply, whatever. Okay. So you do keep, change, flip, and then the normal. If it's cancelable anything, you cancel. If nothing is cancelable, you just rewrite on the proper position. So that's method one. It's suitable only for one fraction divided by one fraction. And then you have a second scenario. You don't have one fraction, you have multiple fractions divided by multiple fractions. For example, do I have the step here? No, I don't have it in here. So if you have multiple fractions, multiple fraction divided by multiple fraction. For example, let's say you have 2/3 plus 1/5 divided by 1/7 plus 2/9. So see, 1, 2, 3, 4. We have 4 fractions. 2 of them divided by 2 of them. So in this case, we cannot do keep change flip. Keep change flip works only for one fraction divided by one fraction. So here you have many ways of doing it, but I'm going to do only one method. We are going to find LCD. And LCD of all the denominators and multiply the numerators. Multiply all the, let me write top, all the top by LCD. So among 3, 5, 7, 9, we find the LCD. And then multiply all the numerators by that. Why? Because if you multiply the numerator by LCD, all the denominators cancel out, and you have just one numerator divided by one denominator, and that's it. You're done. Okay? So 2 types, 2 methods. If you have a single fraction divided by a single fraction, you just do keep change flip and then cancel rewrite. If you have multiple fraction divided by multiple fraction, you cannot do keep change flip. Use LCD, multiply take the LCD of all the denominators, not only numerator, all the denominators, and then multiply all the numerators, cancel, rewrite. Okay? Right? Example 1. Which type? One fraction over one fraction or multiple fraction over multiple fraction? It looks like multiple fraction. But how many division sign you have on the numerator? 1. So it means you have only one fraction. One fraction on the numerator, because even though you have multiple terms, but how many division sign? One division sign. So how many fraction you have means how many division sign you have. So you have only one division sign on the numerator, that means one fraction. And how many fraction you have on the denominator? One fraction. This is not 7, this is 1, okay? 1. So it means one fraction over one fraction, we can use keep change flip. So we are going to keep the numerator. X squared plus 10x plus 24 over x squared plus 13x plus 42. Change the division sign into multiplication and flip the denominator. So x squared plus 7x, and then x squared minus 5x minus 36. It became the normal multiplication we learned in 7.12. So we started with complex, we turned it into a normal one. And now we know how to multiply, right? What are the steps to multiply this? The first step is factor. So let's factor. Who can tell me the first one, the top right? No, the top left. Plus 6 plus 4. Who wants to do the bottom left? That's plus 6 plus 7. Bottom right. minus 9 plus 4. And on the numerator, we have two terms. So what? DCF or perfect square? In order to use perfect square, you have to have a difference. Do you see any minus sign on the top? So definitely not difference of perfect square. So it has to be DCF. What's the DCF on the numerator? So what is left? X plus 7. So we did keep, change, flip, vector. And now what do we do? The fun part. What's the fun part? Cancel. What can we cancel? X plus 4 plus 4 plus 6 plus 6 plus 7 plus 7. So what is left then? X minus 1. See, the complex looking thing becomes only a simple x of x minus 9. So did you enjoy it? Did you like it? Yeah. It wasn't bad. Try the next one by yourself. But always ask yourself how many fractions we have. So how many fractions we have on the numerator? 1, because we have 1 division sign. 1 fraction. So how many fractions we have on the denominator? 1 again, because we have only 1 division sign. That means your life is easy. Keep, change, flip, factor, cancel, divide. Maybe we can just Liliana is here, Martin here, Christopher here, Axel here, Matthias here, Eliza here, Angel here, Honda here, Maria here, Ashley here, Arizona. It changes it here. Jason here, Kathy here, Asim here. Hela, Rachel here, Alicia's here, Mariam here, Kay here, Chanel here, Jasim here, Jonathan here. Wow, today is also perfect attendance. Thank you so much for being here, guys. I really love to see you guys. Ready? Who would like to do a numerator? Justin.
3 minus x.
So you do keep, change, flip. So let me read it first. 9 minus x squared x plus 3 times the denominator we flip x squared minus 5x minus 14, 3x minus 3. Okay, go ahead.
X, minus X and 3 plus X.
Good job. 3 minus X, 3 plus X over X plus 3. I was hoping you're going to say X plus 3, X minus 3. But you guys are smart. You know which one comes first. Mario, which one you have to try? Huh?
You also write -1 parentheses, X minus 3, X plus 3. Yeah, okay.
Mariam, which one want to try? The numerator or the denominator? Or both? Okay. Right. And how about the denominator? Hmm? Two terms. So which method? GCF or perfect square? Eliza. So what is your GCF? 3. What is left? X minus 1. When you two terms, there is only two choices. There are two choices. Either GCF or difference of perfect squares. So obviously you don't see a perfect squares here, so it has to be GCF. So we set up our setting and everything. Now we are going to enjoy the show. How do we have fun? What do we do? What we can cancel? 3 plus X, X plus 3. In addition, the position doesn't matter. X plus 3 is same as 3 plus X. If you don't know that, replace X with 0. If you replace X with 0, you have 3 plus 0, which is 3. 0 plus 3, which is also 3. So you can cancel 3 with 3. And then what do we have? Anything else we can cancel? Really nothing? -7 plus 2. Then we have -1. Yeah, we cannot cancel anything else. It was a boring cancellation. But what is left? So many things left, right? What is left in the new? 3 minus X, X minus 7, X plus 2. And the denominator, we have the second denominator. You don't have to multiply. Don't waste your time by multiplying. Keep it. It's too easy, right? That's why in the final exam, usually they don't ask you this question. They ask you the next type. But before that, Mariam, do you have a question?
It looks similar to the last one.
Huh?
It looks similar to the last
It is rational, but before we did from this step, and now you just have one more step. You break down the complex into normal one, and then we do the exact same thing what we did before. So even this is complex fraction, but actually it's just normal fraction. So final exam has this type of question, and definitely there will be one.
Wait, that question just did or that one? Oh, that
These are easy ones.
Is this considered?
Great. How many division sign we have on the top? One here and one invisible here, right? So 2 fraction. And how many fractions do you want the denominator? One division sign is here, one division sign is here. So 2 fractions. So obviously we cannot do keep change flip because we have more than 1 fractions. 2 fractions over 2 fractions. So we look at all the denominators, not only one denominator, all the denominators you see. What is the LCD of all the denominators? Let me should actually write this down. LCD of 3, 3x, and 4. Definitely for 3 and 4, the answer is 12. And we have a x, right? We have to keep it x. This is the easiest way, okay? There are many other ways you can solve it, but I found this is the easiest and shortest method. Find the LCD of all the denominators you see, and then multiply the numerators. So let me rewrite all of my numerators. 5, 2x over 3, 2 over 2x minus 1 over 4. Multiply 5 by 12x. Multiply this by 12x. Multiply this by 12x and this by 12x. So multiply all the numerators by 12x. Why? Because we don't want to see any more denominators. Our goal is to cancel all the denominators. So look what happens. 5 doesn't have any denominator. So we have 5 and 12, 60x. Now here's the second piece of the numerator. We have 12x and we have 3. We cancel the 12 by 3. We get 4x, right? Well, let me just ignore the x. But look, what do we have? 2, 4, and x. So we have 8x squared. Eliza. 5, 12 by 3. 3 goes to 12 how many times? 4 times. And here we have x divided by x, so they cancel out. And 3 goes to 12, 4 times. So we cancel this denominator. X cancel out. And 3 goes to 12, 4 times. So we have 2 from before and from for now. So what is left? 8. And then you have a minus.
Yes.
Now 4 goes to 12 3 times. So you're left with 1 times 3 times x. That gives us 3x. That's it, we are done. But numerator is more factorable, right? So anytime something is factorable, factor it to see if you can cancel with the denominator. But we are done, okay? We just want to check whether we can cancel anything from the numerator or the denominator. So what can we factor out from the numerator? Between 60 and 8, both are divisible by which number? 4. And between x and x squared, what is the common factor? X. So 4 goes to 60 how many times? 15. And 4 goes to 8 twice with the x. Even though we factored, but there's nothing we can cancel, so we didn't have to factor. So both are acceptable. You should always factor because sometimes after the factoring, you can actually cancel something from the denominator. Okay. But if this is a multiple choice question, if you see that, you're already done. But usually this is not multiple choice question. Any question? So we did only 2 things. Find the LCD of all the denominators, multiply by the numerators, and then cancel. The extra factoring is extra. You can factor, you don't have to factor, but it's always better to factor because sometimes you can cancel after factoring. So I have so many questions. Let me see how many. Let me put them together. Oh, only 2. Oh, no. Are you guys done copying this part? Anybody still copying? No. So for now, 2 questions. Definitely one of them will see the final answer. One of this type, not the same question, this type. The numerator says 5 plus 2 over x. Denominator says x over 3 minus 5 over 6. And with this, you'll be done in 7.7. Is it too small? Let me write bigger. 5 plus 2 over x, whole thing divided by x over 3 minus 5 over 6. And this one says 4 over x minus 1 divided by 3 plus 2 over x squared. No, it's possible, but when you think of something smaller, and you might start asking because you're not putting all the money. X, 3, and 6. Plus velocity among 3, x, and 6. So x, we have to keep the previous one. Because if you decide velocity between 3 and 6. 3 is a common factor. Velocity means multiplication, like time table. Between 3 and 6, you're looking for a big number. The big number is divisible by 3 and also divisible by 6. That's the answer. Yeah, don't get time table. 6 times table and 2 times. Okay. When you're done, you must take 5 planes. I know. That was the video. 6 times that's it. That's it. 6 times 1, 6 times 2. That is from here. Can you divide 6 by 3? That means 6 is also. So you write down the control for the biggest one. And see divisible by another 2. If divisible by another 2, that's the number you're looking for. Looks okay. On the denominator, you take out only x, right? You factor out only x, right?
That is 2x minus
2x minus 6.
I didn't, but I was doing it. I don't know.
You did something. What is your denominators? What is your denominators? They are not same, they are different. One is S, one is D, one is T. Others is. That's why you multiply by 6 so that you can cancel the denominator.
So like I can do
You have to cancel it to make it disappear. You cannot make it disappear here, and you still have x below 2. You still have 3 below x. You still have 6 below 5. These 2 are there. We are multiplying the numerator so that you can cancel them.
But where I was just put it. No, wait. But
So you have 5 over 1. So you simplify the numerator. And then you simplify it down. Then you have 3, you cannot make it disappear. You have to keep it 3, you have to keep it 12.
Yeah.
We can only make it disappear if it's equals to some number, like equals to 0. Then you can make it disappear. But here you cannot make it disappear. This is 15, this is number 17, this is 15 plus 6. 15 doesn't have any x. How can you combine? You cannot combine the 6. You have to have like terms. Remember? 2x and anything with x you can combine. 15 doesn't have any x, so you cannot combine.
Just say.
So it's 15 plus 2x divided by 3, and 8 minus 3 is divided by 12. And then you have one fraction divided by one fraction, so you have to do cube, change, 2. But cancel, you can use cancel.
So it works still.
It works, but there was. Compared to that, in my room it says once you have a LCD, this doesn't have a denominator, but this has x, this has 3, and this has 6. Right? So look, cancel the denominator, no more denominator. This becomes 6, no more denominator. This cancel out, no more denominator. And now you relate what is left. 30x are that. Here you have 12 over x. Here you have 2x and x, so it's 2x squared. And here you have 5 and x, so this is 5x. And you're done.
Okay.
Technically you're done, but if it's factorable, it's factor to z and cancel out.
Okay.
See, so one second.
And then from here, this 6 and this 6 comes out.
But you can cancel PS. Zero 6 is not. So that you don't.
It's weird, yeah.
Vector proceeds
Actually said.
cancel x and x. You didn't have two X, right? You only two of them. Here, two more X. And what are After you're done, proceed both of them are factorable. So factor to see if the same. But you only want to know how to access the square. And one X, you like X, X squared, X, N squared. I don't get the same question. We just delete the. Everything is government, but I found this the shortest one. You solve it in one line. So again. Thank you. One yeah, even it's not a fraction, that's what it is. So we have one fraction. Next up is okay, so this is a complex fraction because we have fraction divided by fraction. Our goal is to reduce it to one numerator to one denominator. See here we have multiple numerator, multiple denominators. What can you do so that you get this one numerator and one denominator? The method is the method I showed you. It says, well, just cancel the denominators. If you cancel the extra denominators, you're not going to have multiple denominators. You're going to have one denominator and one numerator. So our goal is to get all the denominators you see because they make it complex. So it is there. Come on, sometimes after the vacuum so we almost 4x squared minus 1, 4x squared minus 1, 4x.
Yeah, that part.
See one next solution. You cannot represent yes, but still exactly. What we don't know, we do that. Or we do this. The one we know, right? Just one.
Yeah.
Okay, then we're going to get now, and then you're going to go 8.4. My pen is not working. So we have denominators x, 3, and 6. So you're looking at the LCD between x, 3, and 6. It's 6x. Between 3 and 6, definitely the 6. And x is single, so you have to keep it. So you multiply 6x, 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 and 6x. Why we are multiplying? Because our goal is to erase all this denominator. We cannot simply erase, so we brought the 6x into each family. They are fighting, and now the denominators will disappear. This x disappear. 3 and 6, they fight with one another, and they're left with 2. 6 and 6, they fight and double tie. So what is left? 5 and 6x gives us 30x. We have 2 and 6, 12. X, 2 and x, 2x squared. And lastly, 5 and x, 5x. Technically, we are done, but sometimes after factoring, we can cancel. So on the numerator, what is factorable? 6. We left it 5x plus 2. On the denominator, x is factorable, we get 2x minus 5. If it is a plus sign, we could cancel, so you would not, never mind. But in the exam, I'll try to give you something, it's cancelable after factoring.
So what, let's say if I chose that first answer, is that acceptable or do I have?
It is acceptable if nothing is cancelable after factoring. So here, see, we factor for nothing because you could not cancel anything.
So just to make sure I can factor out C.
If something is cancelable. So in the exam, I'm planning to give one question where you can factor and cancel. Okay, so always try to see if it's cancelable or not by factoring. But usually in the final exam, they give you something that is not is cancel. That is not cancelable. Okay, so for the final exam, this is the most they put in the final exam. But for my in-class exam, I'll definitely give something that is cancelable. Okay, Matthew's question.
No, that one.
Oh, okay. Then the next one. We have LCD between x and x squared. What's the LCD between x and x squared? X squared. So multiply by x squared, x squared, x squared, x squared. As a result, all the denominators cancel out. We get x, and here we have nothing. So 4x, 4 from before, x from the cancellation. Minus 1x squared means simple x squared, and then 3x squared, and then 2. But on the numerator, something is factorable, so we get 4 minus x. Denominator, we have nothing, it's factorable, so just leave it. So you factored for nothing, we could not cancel anything. But still, we can do that. So I'm telling you again. In the exam, in class exam, factor, okay? Because you can cancel something after factoring. So that's why I see what you can cancel. I want to give two questions. One will be something that is not cancelable, and one with something that is cancelable. Question, John?
Oh, no, I was just asking about what.
Oh, okay.
Or-
So with this, we are done with 7.5, 7.6, 7.7. Hmm? What is what? Oh, the review sheet. This weekend? Now in chapter 8, we are going to do only one section, 8.4, and that's it. And then we'll go to chapter 10. 8.4 is actually not bad because it's related to real life. But we're not going to use questions for real life. We are going to just use functions. But in real life, we always face two scenarios. If we have relationship between two things, either they are directly related or they are inversely related. If they have a relationship, okay? For example, the money you earn versus how many hours you work. The more hour you work, the more money you get. What type of relationship is this? Direct or inverse? Direct means if one is increasing, other is increasing. If one is decreasing, other is decreasing. So they have a direct relationship. Inverse means if one is increasing, other is going down. Or if one is going down, other is going up. So they have inverse relation. So the money and hour, the more hour you work, the more money you make. What type of relation you have? Direct. The more cell phone you use, the less number you get in your exam. What type of relation? Direct or inverse? See, so you know the relationship. So when two things are directly related, we put them on the same level. Okay? And usually in the relationship, there's a constant rate. At a constant rate, they are changing. For example, the more money you make, the more hour you work, the more money you make, right? But it's at a rate, right? It's your, what do you call? Wage, right? It depends on your wage. If you are earning, let's say $20 per hour, so the money, the more hour you're working, the more money you are getting. The relationship has a constant rate of $20 per hour. So mostly relationship has a constant rate. That rate is telling you how the two things are changing. So here, this constant rate is represented by the what? The letter K. So let's say X and Y, they have a direct relationship. So we represent that with the equation Y equals KX. It means Y is changing with X at a constant rate of K. Okay? Y is changing directly to X with a constant rate of X. And if two things are changing inversely, so one is going up, one is going down. So we represent them using two positions. Y is changing inversely with X. So if Y is on the numerator, X has to be on the denominator. Or you can write X is on the numerator, Y is on the denominator. So one of them has to be on the top, one of them has to be on the bottom, because they have an inverse relationship. One going up, one going down. But at which rate they are changing, it's something called K. K always has to be on the numerator. It's a multiplication. You're multiplying by the rate K. And one is increasing, the other is decreasing. So two types of relationship. Direct, inverse. The formula for direct is Y equals KX. Direct, the relationship for inverse is Y equals K over X. If Y is changing to X. Now let's say Y is changing with X squared. Okay, not with X, but X squared. So we write y is changing directly with x squared with a constant rate of k. Or let's say y is changing inversely with square root of x. So square root of x goes on the denominator. Y is changing inversely with square root of x. So y is in the numerator, square root of x is in the denominator, or you can switch their position, it doesn't matter. The main idea is one of them has to be at the top, one of them has to be at the bottom. So depending on what the direction says, you're going to change the variable, change the function. The main idea is same. For direct, the two variables have the relationship have to be on the same level. So y is the numerator, x is the denominator. They have to be on the same level in the numerator. For inverse relationship, the two variables you have, or two functions you have, one of them has to be on the top, one of them has to be on the denominator. So inverse means top and bottom, direct means on the same level. That's the main rule. And what quotient they give you, it doesn't matter. They can give you xz, yz, or a, b, c, d. It doesn't matter what variable they give you. The idea is same. Now let's do some fun examples. It says write an equation to describe the variation. Use k for the constant of proportionality. So k is the rate. Okay. Now the first scenario, r varies inversely as dq. First thing you have to do is identify which two things are changing. Varies means changing or have a relationship. This is what varies means. R varies, or let's say R is changing. So which two things are changing? In A, in one. R and DQ. Two variables are changing is R and DQ. How they are changing? Inversely. So if R is on the numerator, DQ has to be where? On the denominator. Then what goes on the numerator? Okay. So this is the relationship we wrote in mathematical notation. R is changing inversely with dq with a constant rate of k. Now into what we are given. So R is changing directly with dq. And then what happens to the k? Where do you put k? In front of dq. So R is changing directly as dq. So they both have to be on the numerator. And since they are changing, they have to change with a constant rate. So you multiply by the constant rate. We always multiply by the constant rate. Okay, the second scenario. Mariam. But first, you have to write an equation for the scenario. What's the equation for this scenario? Which two things are changing? Y and X. How they are changing? Directly. So directly means Y equals what? X. K times X. And then we read A. It says find the constant of variation. Means solve for K. How can you solve for K? Means get the K alone. What do you have to do?
Substitute into the value, some way, so y equals 5, x equals 15.
You're solving for k.
Yes. On each side by 15.
Divide by 15. So k equals
1/3.
1/3. This is what they are asking in A. Find the rate at which x and y they are changing based on the numbers they gave us. When y is 5, x is 15. So what is their rate of change? And then B says, well, once you know your rate of change, now write the equation again by replacing your k with what you just found in A. So B, you just have to rewrite the equation. Y equals 1/3 of x. Because this is our equation, right? Y equals k times x. What is k? 1/3. So y equals 1/3 x. So in A, they're just asking us write down the relationship with the equation. In B, it says once you have an equation, now I'm giving you some example. Tell me based on the example what is the rate and what's the equation again by replacing the rate. And now in this scenario, it's saying once you know your k, once you know your relationship with the two variable, now find out more information. I'm giving you more information, so you give me more information. I say suppose y varies inversely with the square root of x. So step 1, identify which two things are changing. Before you read any further, just read the first sentence and tell me which two things are changing. Eliza. Only x?
No, y.
Y and only x? Square root of x. So two things are changing, y and square root of x. How they are changing? Directly or inversely? Inversely means where is our k?
Is
So inverse means y has to be on the top, square root of x has to be on the denominator. And you multiply with that. Who is lost? Tell me, Jason.
whole thing.
Step 1, identify which two things are changing. Can you do that? Look at here. Y varies means changing, okay? So y is changing directly as x. Which two things are changing in this sentence? Y is changing directly as x. So which two things are changing? Y and x. How they're changing? Directly or inversely? Directly. So for direct, it's y equals k times the second variable. Our second variable is x, so y equals kx. Because y is changing directly with the x. On the other hand, this is saying y is changing inversely with the square root of x. So which two things are changing on the right side? Two things. Which two things are changing? And square root of x. So y and square root of x. You write them down. Y equals square root of x. And now how they are changing? Directly or inversely? Inversely. That means they have to have, one is on the top, one is on the bottom. They have to have opposite position. So y equals something over square root of x. Then what goes on the bottom? What goes on the top? Yeah. Is it clear? Let me give you another scenario before we solve this, okay? Just a random scenario. Z is changing with cube root of A. What? Oh, I didn't say the relationship. Changing root of changing directly. Which two things are changing here? Only A? So Z equals cube root of A. How they are changing? Directly or inversely? So directly means K goes where? Next to here. See? If I said they're changing inversely, then Z equals cube root of A. So to solve division problem, the first question should be which two things are changing? It's not only X and Y, okay? See, this example doesn't even have any X, doesn't even have any Y. So you have to consider which two things are changing and then how they are changing. Are they changing directly or inversely? If they are changing directly, means you're multiplying on the same level by K. If they are changing inversely, that means you're multiplying K on the top, the other one has to be at the bottom on the denominator. They have an inverse relationship. Now, are you guys comfortable about the first sentence of any equation? No question? One of these questions will be the final exam, definitely. Okay, so once we know the equation, the first sentence tells us to solve for K. This piece of information is given so that we can solve for K. Okay? So we have y equals 7, K, square root of x is 4. So 7 equals K over what is square root of 4? 2. And now if you want to get this K alone, how can you get rid of the 2? Multiply. So no more denominator. That tells us how much is our K? 14. So that means we know this relationship here. It's y equals 4, not 17. Y equals 14 over square root of x. Now we use the second piece of information. They are saying, hey, I'm giving you 9 now. Tell me for x equals 9, how much y we supposed to get? So y equals 14 over square root of 9. And what is square root of 9? 3. So y equals 14 over 3. That's it. We know y and square root, they are changing inversely with one another. And then we want to know how, at which rate they are changing. So we use the first piece of information. Once we get our rate of change, we know now clearly how much rate we have, with how much rate they are changing. So we use the second piece of information to find out how much would be the y if x is that much. Any questions so far? Okay, try the next one by yourself. Time is it 3:25? Let me put that one check.
Give me one sec.
So fast. You remember fast? Yeah. We're just quiet. You're not done yet, right? Let's take the left side. The right side is a little bit. The left side. You're not done.
So the first one, K equals 5. No,
Did you use the last information? X is 5, Y x is 2, Y is 5. So you found your K is 5. You know your K is 5.4, and they're giving you X is 3. So based on the K and X is 3, minus is Y. Which one is the left, right? The contract is equal rate. And then the possible result is so different. With the numerator part and the yeah. That is the numerator part of the numerator.
Thank you.
One. Y is 50. Right? It's not a number. So it must be X, Y, X one is now. Almost correct. Past information is for
Yes.
okay. But it is the field that you have how have K times 4. How do I explain the field in the first question? The next procedure is
No, he's on the.
So it's 5/4 times 9 times 3. Why? How can you multiply one and
Second one.
We still don't have much time, so let's do them together.
Yeah.
Y is changing directly with x squared. So the two things are changing is y and x squared. How they are changing? Directly. So k goes to in front of x squared. Now the first piece of information is given to us so that we can solve for k. So x is 5, y is 5, we don't know k, and x is 2. So 5 equals k times 4. And I seen a couple of you that confused either subtracting 4 or what. Always look at the relationships. What's the relationship between the two things we have? K times 4. So we need to divide by 4. Not subtract, divide. So k is 5/4. Once we know our k, we can rewrite this by replacing that k, because we know what is k. So this becomes y equals 5/4 x squared. And now we need the second information to get the y. Y is 5/4 3 squared. So it's 5/4 times 9. And then many of you got confused what to do. Well, you know below 9 you have a 1. That means you're going to make a sandwich. Multiply top with the top, bottom with the bottom. So y is 45/4. Okay. So far all the questions we did, either two things are directly related or inversely related. Now in the next one, something is interesting going on. 3 things are changing, and we have both relationship exists. So which 3 things are changing in the next one? X, Z, and only X?
X is second.
So first we are starting with Y. Your sentence started with what variable? That variable should be on the one side. Okay? Here our sentence started with Y. Y is changing. So Y equals. The other two functions are x squared and z. Mariam.
Is it y k times over x?
So z is changing directly. So it has to be on the same level as y, but x square is changing inversely. So it has to be on the other side. That means our k goes on the numerator. So three things are changing with one constant rate. What is that rate? That information we need to find using this information. So y is 5. We have no idea what is k, but z is 3 and x is 2. So 5 times 3/4. Eliza. Multiply by 4, definitely. So 4 cancel out. And how can you get rid of the 3? Divided by 3. So that 3 cancel out. You can do it in 2 steps or you can do it in 1 step. If you want to get rid of something from the numerator, you have to divide both sides by that. If you want to get rid of something from the denominator, multiply both sides by that. So both numerator and denominator cancel out. And we have our k is what? How much is k? 20/3. Just like this one, it's a fraction. 20/3. So now we are going to rewrite our equation. Because now we know what is k. Y equals z x squared. And our k is a fraction. Since k is a fraction, you have two choices. Either write the fraction on the numerator, which will make your life harder, or simply split your fraction into top and bottom. Top goes on the top, bottom goes on the bottom. You can do both together or you can do step by step. Same answer. In the final answer, we have 30 questions to do in only 2 hours. So you should do all the shortcuts because you don't have enough time. So if you break down your fraction, because you already have a fraction to deal with, you can simply put the fraction, the top part on the numerator and the bottom part on the denominator. It's same thing. Let me show you an example. Let's say have, let me do the example here. Let's say have 2 times 1/2. 2 times 1/2 is the same as 2 times 1 divided by 2, right? Or if you have 2/3 times 1/2. This is same as 2 times 1 and 3 times 2, right? So while you multiply by a fraction, the top portion goes on the top, the bottom portion goes on the bottom. If you multiply by a fraction, top goes to the top, bottom goes to the bottom. So you can use the same concept here. 20/3 is a fraction, you're multiplying. So we have k times z/x squared. This is same as kz/x squared. The same thing, okay? So if we have 20/3 z/x squared, you can simply write 20/3 z and x squared. This is same as 20/3 z x squared. This looks bad. It looks complex, but the same thing may look cuter if you write it this way. They're same, right? So anytime your k is a fraction and you already have a fraction to deal with, don't write fraction of a fraction. It's complex. So like numerator on the top and denominator on the bottom of your k. So it becomes much easier looking. And trust me, it makes your life much easier. Now is the second piece of information to find out the y if z is 2 and x is 3. So y is 20/3, z is 2, and 3 squared is 9. We cannot cancel anything, so we simply multiplying top, bottom, bottom. 40/27. And that's what the final answer question. So in the final answer, you have either one relationship, direct or inverse, or a double relationship. It's called joint variation. So either a single variation or joint variation. Or there is one more question I want to show you. Let me know if you guys are done. Done? Is anybody still writing? Or this type of question where no math is needed, logic is needed. But you still need to know your equation. So we have joint variation. 3 things are changing. Which 3 things are changing? X, Z, and Y. So our sentence started with Y, so we have to write Y equals. Oh, I need more space, so let me write here. Y equals. Now Y is changing inversely with X. So where do you put the X? On the same level or on the denominator? Denominator. And directly with Z. Z is on the numerator. Where does K go? On the top. So Y is changing directly with Z, inversely with K, inversely with X, with a constant rate K. Ella, is a question or answer? Now they're asking which one of these is true. If you want, definitely you want to go up. How Z has to change? Does Z go up or Z go down? Z goes down. If Z has a direct relationship, so if Y is changing, Z has to, how Z has to change? Going up or going down? Up. So Z has to go up because Y is going up. Now if Y is going up, X has to go which direction? Down. So we want definitely Y to increase. So Z is what? Increasing or decreasing? Going up, it means what? Increasing or decreasing? Increasing. And X is happening what? Decreasing. So which one is true? Z is increasing, X is decreasing. So which one is true? B. If you want definitely Y to go high, your X has to go down. And you want Z has to go up. So see, it's logic, no matter what. Who is lost?
So what the question is final? Like just
They give you 5 multiple choice, and you have to pick one of them with this scenario. I give you 2 multiple choice to make your life easier. But in the final exam, they'll ask you similar question with 5 multiple choice. And you have to set it,
but it's always it's going inversely, Z is going up and X is going down.
let me give you another example. Let's say A varies directly with B square and inversely with square root of C. If A has to increase, or let's say decrease this time. If X has to decrease, then how B and C will change. So first of all, we have to see what's the equation we have. Which three things are changing? A is changing. I should use different color. Like red. A is changing with B square and cube root of C, square root of C, right? So square root of C goes on the bottom. A is changing directly with B square, inversely with square root of C. Where does K go? On the top. Eliza. This time, we want A to go down, decreasing. So if you want A to go down, then B square has to go up or go down. Which one? A and B, they have direct relationship, right? So if you want A has to go down, your B definitely has to go down because they have direct relationship. Then C has to go which direction? Go up because it's inverse relationship. So B has to decrease and C has to increase. So see, based on the relationship, you know which direction they are moving. Based on what they want. Here they want Y to increase, and here I wanted A to decrease. So based on that, we can figure out the relationship of the other two. So in the exam, I'm going to ask, I don't know how many, but in the final exam, you have three choices. Either a single variation, like one increase in pass or one direct, or a joint variation with math like this, or a logic question like this. Okay? So in the exam, I will definitely going to ask you two questions. If I have space, I'm going to ask you three questions based on three scenarios. And today's what? Today's Tuesday. So Thursday, we are going to do chapter 10 because we are done with this. We are going to start chapter 10 and then the last 30 minutes will be your exam. Okay? So good luck.
Thank you, Professor.
She said I can't chapter 10, last 30 minutes.
Thank you.
Okay.